Hi everyone, welcome back to my YouTube channel. In this video, we are going to be looking at coordinate geometry. Excuse my voice, I'm a bit under the weather. So we are going to be revising on coordinate geometry, outlining the key points and what the syllabus requires us, and then we will look at a few examples from past question papers. Very important, before we even get to looking at examples, we want to master the key points. And before we want to master the key points, we want to understand what the concept of coordinate geometry involves. So in simple words, we can define coordinate geometry as a concept that allows us to actually find measurements of geometric figures that can be graphed with coordinates. Now, let's look at a few formulas that are important, but maybe before the formulas, let's look at what the syllabus requires us to actually achieve. What are the objectives that we should achieve by the end of this topic? First of all, we have our general objective, and for our general objective, we are actually looking at what you will do in general. What will you as a learner do? You will know how to solve problems involving coordinate geometry. That's the general objective. And then we go to specify them. What are the specific objectives for this concept? So by the end of this topic, you as a learner should be able to, firstly, calculate the distance between 2 points given if you're given these 2 points in coordinate form. And you should also be able to find the gradient of the line segment joining these 2 points. You should also be able to find the coordinates of the midpoint when you're given these 2 points. Equally important, you should also be able to find the equation of a straight line given sufficient information. When we're talking about sufficient information, it could have been that you have 2 points, you have the coordinates of the 2 points, or maybe you only have the coordinates of 1 point on this line, but you also know the gradient. So that is sufficient information for you to be able to find the equation of this straight line. Very important, we should also be able to interpret and use equations of the form ax plus by plus c equal to 0, including knowledge of the relationships involving gradients of parallel lines as well as perpendicular lines. So if I tell you that two lines are parallel, by the end of this concept, you should know what it implies in terms of gradient. What does it tell you about the gradient or gradients of these two lines? If I tell you that these two lines are perpendicular, then you should also be able to conclude or decide or even just think about what this statement says about the gradient of the two lines that are perpendicular. And lastly, we should also be able to apply coordinate geometry to quadrilaterals. And I hope you know what quadrilateral means. It's a term used referring to four-sided shapes. So, for example, a parallelogram, a rectangle, a rhombus, etc. So now let's look at a few formulas, not a few, all the formulas and key points that you need to actually know before you even try to solve questions on coordinate geometry. And it's nothing long. You just have to understand and master your formulas. You just have to understand and master your formulas. Now let's start with the first thing. Before we even get to looking at these formulas, we want to understand that we are talking about having something like this, a straight line. And you have this point as point A, and we call this point x1, y1, the coordinates of point A. And the other side, we have coordinates of B, which is x2 and y2. So this is now you having a line which is formed from 2 points A and B. Now, if this is what you have, there are now a few calculations that you need to know about this that you should actually be able to find. The first thing that we're going to be able to find about this line AB is to calculate the length, of line AB. The length of AB, which we'll find by doing or using the following formula. So you can find the length of the line AB by saying x2 minus x1, you square that, and then you will add y2 minus y1, you also square that, and the whole answer, you are going to square root it. Not the most beautiful square root, but you're going to square root this. So we want to take note of that formula that we will use when we are trying to find the length of the line AB. The second thing that we should be able to find, the second thing that we should also be able to find is finding the midpoint of this line AB, like the middle point of between the 2 points A and B. So to get the midpoint of AB, this is, we know that every coordinate, because a point is something with a coordinate x and y. So we know we'll have x and y. So to get the x coordinate, we'll say x1 plus x2, and we divide them by 2. That's what we do when we want to be in the center or in the middle. So we'll add the two x coordinates for the 2 points, A, the x coordinate of A and the x coordinate of B, and we will add the y coordinates, y1 plus y2, and divide it by 2. Then we will have the coordinates of the midpoint. The next thing we want to find is to also be able to find the gradient of line AB. Number 3, we want to know how to find the gradient of line AB. So to get the gradient of line AB, we can abbreviate it MAB. So to get the gradient, because we know that by now that M represents the gradient, or you can also write in full gradient of line AB. You can write it in full as well. So we want to find the gradient of line AB, and to get that, we'll use the formula change in y over change in x. What does that mean? It means y2 minus y1 over x2 minus x1. Change in y over change in x. Very important formulas that we are going to be using when we are exploring this coordinate geometry concept. And then the fourth key point or formula that we want to take note of, don't know why I'm writing ugly numbers, but the fourth point that we are going to be looking at is to actually take note of when we have parallel and perpendicular lines. So when we have parallel lines, so we'll start with looking at parallel lines. When we have parallel lines, or you are told that the two lines are parallel, something like this. If I tell you that this line AB is parallel to line CD, and then I indicate that with an arrow like that to say that these two are parallel, then this line will have gradient 1, so we'll call it M1, and this line will have M2. So what we should know is that when two lines are parallel, they have equal gradient. So M1 is equal to M2. So if I see a question and it's talking about, no, find the equation of a line that is parallel to, then you have an equation. Then one thing that should come to your mind the moment you see the word parallel and you're talking about lines and equations, then you should know they have the same gradient. The second part of this, number 4, is when you have perpendicular lines. So perpendicular lines, if you are told that these two lines are perpendicular, so if I say that the two lines are perpendicular, then I don't know why I'm underlining it, but when I say that two lines are perpendicular, it's something that looks like this. So you have a line, let's call it XY, and then you have another line, maybe PM, and we are saying that they are perpendicular, meaning they are meeting at 90 degrees. So what is special about these two lines is that the product of the gradient, so M1 and M2 are not equal when they are perpendicular, but the product M1 times M2 will give you -1. So very important, we want to understand this. So we want to make sure that we take note of this. So we will say that if we have two lines and we are saying they are perpendicular, then we should know that their product of the gradients is equal to -1. So how do I get this? So for example, if I say that, if we're looking at an example, so if M1 is 3, then M2 has to be the reciprocal. This is 3 can also be written as 0 over 1, right? So it means we'll take the reciprocal of that with an opposite sign, so that when we go and say 3 times -1 over 3, we'll have -3 over 3, which is -1, which means the product of the two gradients is indeed -1, implying that the two lines are indeed perpendicular. Now, very important, I'm going to try and move this up just to make space for the last thing, which is number 5. Very important, the last thing we want to be able to do is to be able to find equations of straight lines. So equations of straight lines. Now, when we are at equations of straight lines, so when we're finding equations of straight lines, we should use either the following formula. So firstly, we can use y minus y1 equal to mx minus x1. That's one way of finding our equation of a straight line, where m will be the gradient. M will be the gradient of this equation, while x and y, x1 and y1 is a point. It's a point on that line, on the given line that you're trying to find the equation of. So if I know that I know the gradient and I know one point, then that's enough to find the equation. If I don't know the gradient, but I have 2 points, I should also be able to find the gradient, and I choose one of the points to find my equation. So another way to find the equation of a straight line is to say, okay, I can also say y is equal to mx plus c, because from graphs of functions, we should know that this is a standard equation of a straight line. So I can put it, since we're talking about straight lines, we can write it in this form, y is equal to mx plus c. I should just know that m represents the gradient, and c represents the y-intercept. So then I'll be able to use either of the two formulas to find my equation. Now, next we're going to look at some examples. And so I'm going to end this video here so that it's not too long. In the next video, I'm going to look at some examples